Hi, in this video, you're going to review how to conduct an independent t-test using JMP. So I have opened up Colleges with Mean ACT 2, and so I want to know, is there a statistically significant difference between private schools and public schools when looking at grad rate? So I need to first go through my assumptions, and the first assumption is, hey, is this from a random sample? Have I pulled these out of a hat randomly? Have I used a table of random numbers to choose this data? That is the first assumption. The second assumption is normal distributions, and so I'll walk you through that. But I want to show you something really quickly, something I notice people mess up on a lot. You've got to make sure your data set is correct, where you would have your groups set as nominal variables in one column. You see, sometimes people would say, okay, we're going to put private here and public here, okay, and then put the grad rates in these columns. No, no, no. Do not do that. Instead, you set up the type of school as nominal variables, okay? So let me delete that. Okay. So what we will do, we're going to go to Analyze Distribution. Now I've got to look at it for each group. So I've got my grad rate, that's my dependent variable. Remember, dependent variables are going to go into the Y column. It's how does X, how does groups affect Y? So now I want to put my groups, my type, into by. So it's going to divide it up. Now I'm going to click OK. And then I'm able to look at the descriptive statistics to check my normal distributions. So just looking at this, it looks pretty good. My skewness is between -1 and +1. I don't even have to look at kurtosis. And then if I look at public schools, let's see, I've got this zoom toolbar. I need to move it out of the way. We've got skewness, it's fine, kurtosis is fine. So I can assume that I have fairly normal distributions here. Also, when I report my means and standard deviations of each group, I need to, like, this is what I would actually look at, okay? So I can eyeball this and go on and tell you that private schools have higher rates, but I just need to know, is this statistically significant? So I'm going to close this out because I've got to go through my third hula hoop now. I've got to see, do I have equality of variances? So what I'm going to do, I'm going to go to Analyze, Fit Y by X, and then my dependent variable is grad rate, and then my independent variable is the groups, the type of school. So I click OK, and then you go to Unequal Variances. And you will see that it shows you the p-value for the Levine's test. And this is, I'm asking, hey, are the variances between private schools and public schools pretty much comparable? Like, remember how you calculate that variance? And we want to know, hey, is the way they all kind of vary from the mean in public schools pretty similar to how they vary from the mean in private schools? Because, like, if in the public schools, if there's a lot of variance, like scores are all over the place in this group, but not in this group, that's not a fair comparison. It's like we're comparing apples and oranges. So when I look at the Levine test and it's above a 0.05, this is saying there's not really any differences in the variances between the two groups. So you want this third hula hoop to be above a 0.05. Remember the Adam Levine song? He was dancing and he's acting all crazy. It's above a 0.05. So my assumptions for homogeneity of variances are met. I would report the Levine score. Now I can finally do the independent t-test. So what do? I go to Fit Y by X, and I go put the grad rate as a dependent variable, and then we're going to put the type of school as the X variable. And let's see, let's hang on tight. Okay, so what I've got to do, that kind of gives me a visual of how private versus public play out with this spread of scores. But I got to see, is it statistically significant? Here we go. I hit the t-test. Voila, look at that. It is. It is statistically significant when I'm using a non-directional hypothesis. And so I should have set my alpha, I keep forgetting to do this in videos, at a 0.05 because how many is in here? How many n's do I have? I should have probably looked at that first. All right, let's hold on. Let me see how much is in my data set here. So how do I do that? I'm just going to look overall at grad rate. How many? I've got 195 that I'm dealing with here. Okay, that still means that I should have an alpha of a 0.05. If I had more than 250 here, I would probably set my alpha at a 0.01. But let me go back to what we were looking at. All right, I just want to make sure you can see this because sometimes, you know, JMP, Zoom, you can't see what I see. All right, so you will see that my T is pretty big, and the bigness is based on the sample size, okay, and the degrees of freedom. But this is statistically significant because right here it shows that the p-value is less than 0.0001, meaning that, wow, it would be so rare to find a T that big if the null hypothesis were true. There is a less than 0.0001 chance that I would have accidentally or randomly found this difference if the null hypothesis of the population were true. So this is a statistically significant difference. So I would report the t-value, the degrees of freedom, which Dr. Weimers and I don't understand why this is a decimal. We just don't understand. But you're going to report it as a whole number and you're going to round. So 189 is the degrees of freedom. You will report the p-value for the non-directional hypothesis because most likely you just said your null hypothesis was there's no difference. You didn't say, you didn't hypothesize that one would be higher than the other. Now, if you had, you would be looking at these different tails. So let's say your alternative hypothesis, that what you think as a researcher is, I think that public schools, I think that private schools have higher, okay, I gotta think about this. All right, look what this says. It says public and private. So I really should do it in that direction. So if I think that public is less than private, I would be using this. If that's my alternative hypothesis, this would be what I would look at, okay? So, and if I thought that public was higher than private, that's my alternative hypothesis, the opposite of the null hypothesis, then I would look at this. So indeed, not only are there differences, but private is higher than public. But before you do any of this analysis, you need to set in your head, am I just using a non-directional null hypothesis? And most of the time, that's what you're doing, and you look at this t-value right here. Now, because there is a statistically significant difference, now you get to report power. So to do that, you go here, and you go to power, and you click solve for power. And this shows, we are like 100% sure that we were correct in rejecting the null hypothesis here. That's a huge power. That means the way all this math worked, this shows me the percent chance of correctly rejecting the null hypothesis, of really making that right decision. So that's great. Now the other thing that you would need to do is calculate this using the effect size calculator. Okay, so to look at the effect size, I'm going to calculate the Cohen's d. I think this calculator does a better job than maybe one we saw with a one sample t-test, which only that calculator didn't produce a Cohen's d for an independent t-test. So go to this one, and you would enter the mean score of one group. So this would be private and how many were in that sample. And then this would be public. And then you just hit calculate, and it shows you a Cohen's d of a 1.05. Is that big? Well, look in your Hatcher book and find out. But yes, indeed, it was a large effect size. Not only is there a statistically significant difference between the groups, but it's a big difference, all right? So that is how you conduct an independent t-test using JMP.